supposed to verify that each is an identity. For number 1 here, I would change 1 divided by secant squared of theta into cosine squared of theta. That's a reciprocal identity. Do the same thing for 1 over cosecant squared, change it to sine squared of theta. Then using trig identity number 1, cosine squared of theta plus sine squared of theta is 1. As soon as the left side and right side are the same, then you're finished. Number 2, I would change any trig function that wasn't sine or cosine into sine or cosine. Cosecant of A is 1 over sine of A. Secant of A is 1 over cosine of A. At this point, this is what I like to call being on autopilot. When you have a complex fraction, make it non-complex. Instead of dividing by 1 over sine of A, multiply by its reciprocal. Instead of dividing by 1 over cosine of A, multiply by its reciprocal. Still on autopilot, we're just simplifying. Sine times sine is sine squared. Cosine times cosine is cosine squared. Then using your trig identity, sine squared plus cosine squared is 1. So the left and right side are both 1. Number 3, I would change tangent of y into sine over cosine. Since I've done that, I'm going to have to add that to the 1, so I would get the 1 to have a common denominator. So I'd make that cosine over cosine. Do the same thing in my denominator. Change cotangent, the cosine over sine. Change the 1 to sine over sine. So I have common denominators. Once you have common denominators, then you add the numerators, leave the bottoms the same. So we got cosine of y plus sine of y over cosine of y, divided by sine of y plus cosine of y over sine of y. Instead of dividing a fraction by a fraction, multiply by the reciprocal. Cosine of y plus sine of y is cancel on the top and bottom because you're multiplying by them, and you're just left with sine of y over cosine of y, which is what the right side was all along. Number 4, if you factor cosine squared out on the left, so you're left with 1 plus tangent squared of x. Then, if you recognize that 1 plus tangent squared is secant squared of x, and then if you recognize that multiplying cosine times secant, those are reciprocals. When you multiply a number by its reciprocal, your answer is always 1. So the left side is 1, and so is the right. For this problem, we factored, then use an identity, then use another identity. A lot of unique ways to do number 5. One method for number 5 would be to take the left side, 1 minus cotangent to the 4th of x. Recognize that's the difference of two squares. So if you factor it, you get 1 minus cotangent squared of x times 1 plus cotangent squared of x. You may recognize then that 1 plus cotangent squared of x is the same thing as cosecant squared of x. That's great because we're trying to get cosecants in the problem because the right side is all cosecants. To continue further, if you investigate more closely cotangent squared of x, that big set of red parentheses, we need to replace that. If you go back to the trig Pythagorean identity and you get cotangent squared of x by itself, you get that it's equal to cosecant squared of x minus 1. So if you substitute in for cotangent squared of x with cosecant squared of x minus 1, it gets you this. What is so great at this point in this problem is the left side, we're only using cosecants, which is what the right side only uses. If you simplify the leftmost set of parentheses to get rid of the red parentheses, distribute the subtract sign. Combine like terms, 1 plus 1 is 2. Then, using the distributive property, distribute cosecant squared of x. 2 times cosecant squared of x is 2 cosecant squared of x. Cosecant squared of x times cosecant squared of x is cosecant squared of x to the 4th. That's what the right side was, so we are finished. For this one here, I would change my secants to 1 over cosines. And then in turn, change the 1's to have a common denominator of cosine over cosine. Same thing in my denominator. The right fraction I'm not going to change, because it's pretty simple the way it is. Once you have common denominators, you subtract the numerators. So we got 1 minus cosine over cosine of x. On the bottom, we got 1 plus cosine divided by cosine of x. The right fraction stays the same. We have this complex fraction on the left, which instead of dividing by the denominator, we can multiply by the reciprocal of the denominator. Notice the cosine of x's cancel in the numerator and denominator, leaving us with 1 minus cosine of x over 1 plus cosine of x plus cosine of x minus 1 over cosine of x plus 1. We have common denominators already, so we can add the numerators together. If you combine like terms, 1 minus 1 is 0, minus cosine of x plus cosine of x is 0. So we have 0 divided by 1 plus cosine of x. 0 divided by anything is 0. The right side is also 0, and that makes us real happy. Number 7. I would get common denominators for these two fractions so we can multiply them, or so we can add them together. On the left, we need a 1 minus cosine of x. You multiply it times the top and the bottom. The right fraction, we need a 1 plus cosine of x. So you multiply it times the top and the bottom. Once you have common denominators, add your fractions together. In addition to adding them together, I'm also multiplying the things that need multiplied. For example, cosine of x times 1 minus sine of x is cosine of x minus sine of x cosine of x. Cosine of x times 1 plus sine of x is cosine of x plus sine of x cosine of x. And then in my denominator, I can multiply 1 plus sine of x times 1 minus sine of x. I get 1 minus sine squared of x. If you combine like terms, in your numerator, your minus sine of x cosine of x cancels with your plus. Cosine plus cosine is 2. Also, your denominator, 1 minus sine squared of x, that becomes cosine squared of x because of the Pythagorean identity that you see here on your right. You can then cancel a cosine from the numerator and denominator, leaving you with 2 over cosine of x. 2 divided by cosine of x, if you reciprocate cosine, you get secant. So it's the same as 2 secant of x, which is what the right side was all along. Number 8, if you change secant to 1 over cosine, leaving the squared of courses, then multiply sine of squared of x times 1 over cosine squared of x. Sine over cosine is tangent, therefore this is tangent squared of x. That is the same thing as secant squared of x. That's one of the Pythagorean identities. That's what the right side was all along. Number 9, find a numerical value of one trig function of each value of x. You're finished when you have one trig function by itself and you have a number on the other side of the equation, only a number. If I divide both sides by 3, that gets 2/3 on the left. If I then divide both sides by sine squared of x, I get 2/3 is cosine squared over sine squared of x. Cosine over sine is cotangent. Square root both sides. You get cotangent is plus or minus the square root of 2/3. Having a square root on the bottom is not acceptable, so if you multiply the top and bottom of the fraction by the square root of 3, you get plus or minus square root of 6 over 3. That's one possible answer. That's actually two possible answers. There's 10 more answers that you can see on the answer key. It can be any of those 10. This one here, as noted several times throughout this homework, 1 minus sine squared of x is cosine squared of x. Square root both sides, you get cosine of x is plus or minus a third. That's two different answers because of the plus or minus. You only need one answer. And if that doesn't match up with your answer, check the answer key for the other possible answers. So in here, 1 plus tangent squared of x is secant squared of x. Also, 1 divided by secant squared of x is cosine squared. Sine squared plus cosine squared is 1. If you square root both sides, you get secant of x is plus or minus 1. It's one possible answer.